Welcome to part 2 of Competency 13 quiz. In this video, we will continue working with probability and methods of counting. Number 9, an ordinary die is rolled twice. What is the probability that the first roll will land on a number less than 3 and the second roll will land on a number greater than 4? Okay, so you have two rolls. So, and will tell you to multiply. So what do? We set up our first roll, our fraction for our first roll. How many numbers are desired? Well, that would be the number 1 and number 2. So that means two numbers out of 6. Now let's multiply. And on the second roll, well, greater than 4 would be 5 and 6. Okay, because we're using an ordinary 6-face die. That's what this first wording tells us 1 to 6. Okay, so that gives me 2 out of the 6. Okay, we just push enter, and that's 1/9. Okay, pretty basic question, but if you don't know what they're asking and you don't know the keywords, I could see you having trouble with it. Okay, but we're good. All right, so number 10. If you draw two cards from a standard deck, so that tells you 52 cards in a deck, okay, one at a time with replacement. Okay, that's pretty convenient because we don't have to worry about, our denominator changing, okay, or even the numerator, depending, okay. What is the probability that the first card is a black king and the second card is a 10? Okay. Well, the word and tells us we're multiplying. And then we have we have a black king first and a 10 second. Well, if you know your standard deck of cards, then you're going to be good to go. So we need our fraction first. Okay, how many black kings do we have in any deck? Well, we only have two of those, and the deck has 52 cards. Okay, that's the first draw. Remember, we are only drawing one at a time. We are drawing two cards. Okay, now we multiply, and then we have a 10. Well, there are 4 10s in any deck. So let's set our fraction and 4. And now we are replacing when we're done with the first draw. So that means we still have 52 cards in the deck. All right, so now let's push enter. And there we go, which that is option B. Okay, all right, so now let's look at number 11. Okay, the probability of that Yan will go bike riding today is 3/4 or 3 out of 4. The probability that she will go bike riding today and that she will bike ride at least 1 mile is 5/8. What is the probability that she will ride her bike at least 1 mile given that she goes bike riding? Okay, that's important. She has to go bike riding in the first place. So she's on her way. So what are our probabilities? Okay, there's some key things going on here. Okay, the first thing I see the word and, okay, and then we have this whole phrase here. Now don't be confused. They're saying here, you see how you have the word is, okay, before 5/8, okay? They give you the probability that she's going to go bike riding. Okay. She will go bike riding today. Well, that's 3/4. Okay. And they state that first. So she's gone bike riding. So here, let me clear out the calculator. So first she goes bike riding as we have in the sentence. Okay. So that's 3 out of 4. So here she is bike riding. Then you have the word and. Okay. That's multiplication. That she will bike ride at least 1 mile. Okay, this is confusing. Read the sentence in its entirety and interpret it that way. If you read it in chunks, you're gonna think that this second underline here, let me highlight it. This part I have highlighted equals 5 over 8. It does not. It actually equals X. So putting this in my calculator right now isn't going to help. So let me clear this out and show you quickly. Okay? This is what this sentence says. Let me read it again. The probability that she will go bike riding today and that she will bike at least 1 mile. That goes together. Both those things is 5/8. So this is what we have. 3/4 times. I don't know the probability of the yellow. That's X, okay? And this bike riding, since she's gone, is 3/4. And that equals 5/8. So what do we really need to put in our calculator? Well, we need to divide both sides by 3/4, okay? And what will that get us? Well, let me put it in the calculator. All right. Here, let me write it out for you, okay? Over 3/4. Don't bother changing those to decimals. You could, but it's a waste of time. So I'm going to put in my fraction, but you have a fraction divided by a fraction. So put in another one, okay? Do them one at a time because look at how it could be confusing, okay? So 5 over 8. Now go down. That's my first fraction. Now I push fraction again. Now I put in my 3 over 4, push enter, and it is a 5/6. All right, let's try number 12. Number 12, a bag of 24 blocks has 2 square blocks, 4 round blocks, and the rest are triangular blocks. Okay, that would be 18. Okay, all right. If you select 2 blocks one at a time with replacement, what is the probability that at least one block is a triangular block? Okay, that implies addition, and that is one or the other, but not both, which we discussed in an earlier video in Competency 13, and that is would be the difference between mutually inclusive and mutually exclusive. Okay, but either way, you just need to know the formula. So what is that? First, we're going to set up our fraction. Okay, the first one would be what is the probability of pulling that block? Here's our total. So we have our part of our total, and we're saying triangular. So that would be 18 out of 24. Okay, now we have to talk about uh, the second draw. So we are adding because it says at least one block. Okay, so here's our fraction. We have 18 over 24. Again, but here's where you need to remember this is where the subtraction comes into play. You have to subtract both happening. Okay, well, that's multiplication because the word both implies multiplication. So this is what you can do. Now, there's a couple of ways to do this, but this is what I like to do. I set up my fraction and I'm okay. So that would be the same thing you see added, but instead it's multiplied. So what would that be? 18 squared, okay, over, let's see, 24 and squared, okay? All right, now I can write that out if it'll make you feel better. So this is when you're saying, that you want or at least one. They all interpret to the addition. But the way it's saying, when we say at least one, you're saying, well, we don't want both occurring at the same time. So you have to subtract out that possibility, which would simply be the same thing multiplied. Okay. All right. Okay. But I wouldn't write all that down if you can see it quickly. This is a really good question where you can see it pretty quick. Okay. So the way I've typed it in is Probably the best way to do it. So let's enter. Okay, there we go. Option D. All right, let's look at 13. How many different ways can all the letters of the word rabbited be arranged to form a sequence of 8 letters? Okay, this is a situation we discussed earlier about repeated letters or something repeating. Okay, so we have 8 letters total. Okay, so let me clear this out and show you what we need to do. Set your fraction up. You may or may not remember the fraction. You first, we're talking about permutations because once you select a letter, you're not going to select it again unless it repeats. Okay, so we have to it's this is kind of like you can think it as an upside down from probability, but it's a method of counting rather than probability. Okay, so it's total over the repeated parts. So how do we handle this? Well, it's a permutation, so that would be 8 out of 8. So 8 prob number one's what we want. Don't forget to press 8 again. So that's what you need. Now, you have to oh, sorry, pardon me. You have to divide out the 2 repeats. Okay? So B is repeated twice and E is repeated twice. So you have 2 and 2. So you have to multiply those out as permutations. So I have 2 prob, number 1 and 2 again. Now you have to plus Mina, push multiplication. So you have 2 prob, number 1's what we want, 2 again. That's the setup that we need, the total over the 2 repeated parts, okay? And push enter, and that's the correct option, A. Okay, let's move on to number 14. Okay, now 14 is more of a properties. Do you know this simple property? Now you could test each one of these. Sure, let me clear this. Which one of the following is equivalent to a combination of 5 out of 30? Okay, 5 out of 30 combination. Well, you could put them all in, but I see it. It's B, okay? Because I know my properties, okay? Not something we talk about a lot in college math classes or even high school. However, you need to know these things, okay? So let's do a quick putting it in the calculator. So 30 prob, you need number 2, and we need 5 out of that, okay? So push enter, okay? Now try B, okay? I'm going to go do a capture and a type over of 25. Oops, I didn't do that very well. Okay, there we go. Now enter. It's the same thing. Okay, this is a situation of subtracting them, and it's very handy. And I've actually gotten problems correct because it doesn't matter if you're talking about what you chose or what you didn't choose. Okay, there are 30 total in our combination, but did I want 5 or did I want 25? Luckily, it doesn't matter in this situation. Now, you could try the others. Of course, the permutation isn't going to work. Okay, we could try the 20 prob and then the number 3 to get our factorial, and then plus and 5, and then prob 3 to get the factorial again, and enter. And of course, it isn't the same thing. All right, let's go to number 15. Number 15, a student is selecting courses for next semester. The student must take a course from one of the following different courses from each subject offered. You have English, math, science, and history. One of the math courses is calculus, and one of the English classes is poetry. What is the probability that the student's schedule will consist of calculus, and poetry. Okay, so that means we're only concerned with these two. And, okay, it's saying the probability. Okay, we have probability. They use the word and, so that implies multiplication. So we need 1 out of 5 times 1 out of 7. Set up our fraction, 1 out of 5, and you can probably already see what the answer is. This is not a tough one, mathematically, that is. Reading the problem, the words, is what makes this tough. So when you come across these, you know how to pick it apart. Okay? They didn't ask you about science, they didn't ask you about history. That's just extra information. Always make sure you read through it quickly and go back and ensure that you're looking at the question. And we did, and we have it, and we push enter, and it's option D. 1/35 of that particular probability. Okay. All right. Let's look at number 16. Okay. A fair die is rolled 200 times. Okay. They use that wording fair die a lot because it helps with other types of stats. But for us, it's just information and it's good. So we move on. Okay. Below are the results. So they give us a table and we know that our total is 200. Now let's look at the actual question. If this die is rolled twice, so we know we have two situations going on, two events, what is the probability that it will land on an odd number on the first roll? Okay, so we have odd going first. And, well, we know that implies multiplication. And on the number 4 on the second roll. Okay, so we want the number 4. So this is what we want for the second one. Now for the first one, what are we going to need? It says odd. Well, that is 45, 10, and 20. How do we set this up in the calculator? Let's clear this out. Our first event is odd. So put your fraction in. You have to add those all up in the frequencies are added in our numerator. So 45 plus 10, okay, and then plus our 20 in our total. That's our part we're asking about. So that's everything for our part. Now our total is given to us as 200. Now we know that we are multiplying because of the word and. Now we have another event. So let's set up our fraction and the numerator is determined to be 50, same total of 200. Okay, push enter, and that's option A, 330 seconds. Okay, that's the last question for this particular video. Thank you so much for checking out our new website. More and more people are getting on. It's greatly appreciated. I'm still working on everything to build it. I'm not done yet, but the liking, sharing, and subscribing of the YouTube channel is phenomenal and increasing every day. So, thank you very much to everyone who is supporting our efforts. And remember, if you purchase something from the website, this is a money making proposition. It's just simply to keep everything going. That's all it's about. We're not doing it's not a money making venture. I just want to see that everybody who tries to pass their certification achieves that. It's like one of my big goals in life. I don't know why, but you guys are the best. Thank you very much and happy testing.